Have you ever wondered how a water dam ends up lighting your home, or how sunlight powers a calculator without any batteries? Welcome. Today we'll explore the fascinating journey of energy as it changes its form to serve our needs. In our everyday life, energy doesn't always come in the form we need. We may require light, but nature may give us motion, or perhaps chemical fuel. That's where energy conversion becomes magical. Energy conversion allows us to make use of available energy by transforming it into a form that's more useful for us. From hydroelectric power stations to household gadgets, this principle powers our world. So understanding how energy transforms, like mechanical to electrical or chemical to heat, helps us build smarter and more efficient technologies. Let's start with one of the most impressive transformations, turning moving water into electricity. In a hydroelectric power station, water stored in a dam reservoir possesses potential energy due to its height. As it falls, that potential energy changes into kinetic energy, the energy of motion. This rushing water hits turbines at the bottom of the dam. The moving blades now convert the kinetic energy of water into rotational energy. Attached to these turbines is a generator, or dynamo, which transforms this rotational mechanical energy into electrical energy. As you can see in the top flowchart, the chain is simple but powerful. Mechanical energy, rotational energy, rotational energy. Next, let's explore how electrical energy becomes the driving force behind almost everything we use. In an electric motor, electric current flows through a coil suspended in a magnetic field. This creates torque, a turning force, causing the coil and the shaft connected to it to rotate. And voila, electrical energy becomes mechanical motion. You see this in washing machines, ceiling fans, mixers, and even electric cars. On the other hand, the same electrical energy can be converted into heat in an iron, into light in a bulb, or into sound in a speaker. Just follow the MIDI section of the flowchart. One form of energy, many useful avatars. Energy can also convert between lesser-known but equally amazing forms. For instance, microphones convert sound energy into electrical signals, while loudspeakers do the exact reverse. Chemical energy stored in batteries becomes electricity when you turn on a flashlight. When a candle burns, its chemical energy becomes both heat and light, lighting up your room and warming your surroundings. And in nature, plants absorb sunlight and store it as chemical energy through photosynthesis, a process that fuels almost all life on Earth. Now let's go a little deeper into some lesser-known but important energy conversions. In a thermocouple, when two different metals are joined and heated, they generate electricity. This heat to electricity conversion is vital in industrial sensors. Charging a battery converts electrical energy into chemical energy, storing it for later use. Discharging reverses the process. In solar cells, light energy from the sun is directly converted into electrical energy. That's why you can power calculators or garden lights without any plug or battery. Energy is versatile. These conversions prove it. Every machine around us is a masterclass in energy conversion. Electric motors turn electricity into mechanical rotation, powering fans, washing machines, and escalators. Vehicles convert chemical energy from fuel into kinetic energy for motion. Solar panels turn sunlight into electricity, lighting homes and powering satellites. And windmills use kinetic energy of air to generate electricity. Without these conversions, modern life as we know it would come to a halt. Let's quickly recap what we've learned. Energy is never created or destroyed. It only changes form. This transformation allows us to make use of whatever energy source is available. Whether it's a falling drop of water or a burning candle, a spinning motor or sunlight on a leaf, energy is constantly shifting form, helping us do work. By understanding these conversions, we build better machines, harness natural resources more efficiently, and pave the way for a sustainable future. I hope you now appreciate how essential energy transformations are, from your home appliances to power grids and nature itself. See you in the next session with another fascinating concept of physics.